I'm going to start by talking a little bit about containers. The first thing I'm going to talk about is the difference between a container and a virtual machine. So on the right there, you've got a bunch of virtual machines running. The thing with virtual machines is the virtual machine kind of pretends to be a unique system, and so it runs a full copy of each guest operating system on each virtual machine, and then puts your dependencies and your app on top of that virtual machine. So you can see there's 3 copies of a very similar guest operating system just running time and again, and so it's quite wasteful. Docker, or containerized Docker applications, are different because what they do is they don't virtualize the operating system. Instead, they create a sandbox in which your app and your app's dependencies can run. So it's much more of a kind of sandbox place to run applications than it is a whole virtual machine. But you can run enough of as little or as much of the sort of change to your system in that container. So what you're doing is wrapping up your application and its dependencies into something that feels much like a virtual machine, but it's just a sandbox thing, and it shares a lot of that operating system around. So that's the example on the left. So let's talk by talking a bit about how Docker came to be. Let's find the right talk. Let's start here. Okay, so the history of kind of containerized applications really starts in the 1970s with this thing called change root on Unix operating systems. So what this was a command that said, for this running process, I'm going to change where you think the start of the whole system is. So Unix systems all have a path system underneath root. So you have /home is your home directory, for example. But I'm going to change where the root of the drive is. So you think the root of the whole, and the root of the path is the root of the whole system. All devices, everything in a Unix system has an address under /root. So I'm going to change where you think root is, and so you can't go outside that. So you're in a sort of little container. Well, that grew over time into various, and actually that, along with various other kind of isolation techniques, is what led to this really cheap Unix-based hosting. So this, couple of dollars a month shared web hosting. This is the stuff that led to PHP being popular. Why? What's that web thing called? WordPress being popular. Why? Mark Zuckerberg, when he was a teenager, sitting in his dorm room, was playing with PHP other than something else because it was really cheap and free to play with. So that idea of containerizing an app, or putting an app in a kind of little jail, grew until we had this thing called LXC, which was a Linux container engine. And then that was then the first engine that led to something called Docker. So what Docker is, it takes the idea of running apps inside this tightly sandboxed container, but also adds the idea of images. So you can take an application, its dependencies and everything it needs, wrap it up and turn it into an image, and also provide diffs between those images. So Docker images are built on top of other Docker images, and it's efficient. So if I have an image and another image based on it with only a few changes, we don't keep 2 full copies of the image, we only keep the diffs. So it's a highly efficient way of storing data across multiple systems. So here's a quick example. If I go to anything with Docker installed and type docker run hello world, something will happen. What will happen is the Docker engine will look for an image called hello world on my local machine. If it doesn't find it, it goes to Docker Hub, which is a place to keep images, and then downloads the image from there. It then runs it, and now runs this tiny process, and all it is a program that says hello world, but it does it inside a container. We can build on top of that and say, okay, let's go to Docker Hub and find something else. So I can run pretty much a whole operating system, Ubuntu, and run that from Docker. And that'll bootstrap up, download, and run, and give me a interface. I'm now running a complete operating system wrapped up inside a container. So I can build on top of that. Let's go to hub.docker.com and search for .NET Core samples. So you do that, and what you find are these .NET Core samples. So what these are little sample apps built in .NET as Docker images. So what happens if you run these? You'll go .NET run this, it will go and fetch this image, and this image is a root Linux operating system, the runtime things you need for .NET Core, and a sample app, and it will bootstrap that up. So we go .NET run. In this case, we're going to give it a port. So that's going to say you're going to boot this application, open up some ports between my machine and the containerized application, and run it. So if I do that, it's going to start up, and now you see it's running the actual .NET application, that Kestrel server, inside a container. I can point requests to it, and if I go HTTP localhost, bang, it's running that sample app inside a container. So this stuff is amazing. If I've got some application I want to use with my application, say it's a Redis server or anything I want to try out a new version of SQL Server, there are images for SQL Server. I can just get the image, boot it, run it on my app without having to install it anywhere else on my app. It stays containerized in my application. If I want to try a different version of SQL Server to test out some feature, I can get just that image, run it, try it out, then throw it away. So that's containerized applications. How do we go about making our own containerized applications? Let's take a look at that. What we do is we create, next to our .NET application, a Docker file. What I'm going to show you is the kind of common best practice for building a Docker file for my .NET application. So when you look at a Docker file, it starts with this thing called from. And that from command is saying the image I'm going to start with and then build my stuff on top. So if I take a look at that from, it says from mcl@microsoft.com .NET Core SDK 3. That's the name of an image. If I go and look on the Docker Hub and find that image, here it is. I can find it on GitHub, and that's got its own thing from build pack deps buster. And that's got another one, until you get right the way up to a source image, which is actually the source image for Debian, which is a Linux operating system. So it's images built on images built on images. So that means if you keep adding your stuff to certain images all the time, you can build your own image and then use that as the base for all your applications, if you so want. So you start from an image. Now what we're going to build here is a .NET Core web application with Angular. So in order to build this, I need to, from my image, install some dependencies to run Angular. So this next line of code just installs Node. Now what you're looking at here underneath the run are just Linux commands. So what I like about this is there's no magic to it, it's just the same Unix commands I will run anywhere inside Unix to get stuff to work. But I won't spend too long on it, this is a .NET Core talk, not a Linux talk. But yeah, you just put the commands in, you run the installer, and actually go and run npm, install the Angular CLI. And then what you do is the best practice here. Normally if you run .NET build, it will do a restore. So if you run .NET publish, it will automatically do a restore and a build and then a publish. But if you do that, it does that all in one step. If I do a .NET restore separately inside a Docker build, it means the result of every operation is a new image. So if I run the .NET restore 2 times in a row and it's the same result, it will recognize that as being the same result, and so it won't publish a new image for that piece. So it caches the result of that .NET restore and means there's less traffic to move around when I'm publishing that image about. So the best practice here is, once again, make the restore step a separate step, and then later on do the build and publish. So then further on we do the publish operation, and then what we do is, you'll notice here we started up with this from .NET Core SDK 3. Now that is an image that contains the full .NET Core SDK, so it's quite big, it contains all the tooling we need. But we don't need all that tooling at runtime. So what we do is we create one image and use that to do the build, then we grab the output from that build and push it to another image, which is our runtime image. So that doesn't contain the full SDK, that just contains the .NET runtime. And that's that from .NET Core ASP.NET 3 as base. Then we copy our publish files into there, and finally we say, all right, when you start this container, run .NET with our DLL. And that's it, we've containerized our app. You want to test that locally? Just run .NET build and give it a name, and it goes and runs that build. One thing that's really good about this technology is if you can get it to work on your machine, it'll work on any system because it's using a container. Generally what makes things break are dependencies. you're running it on your machine, and you go to a CI server and run it on that machine, there's something not installed on that machine that you had on your machine, and it breaks, and you're going to debug that. If you have containerized builds, not only do you fix the works on my machine problem, you also fix the builds on my machine problem. So you go through and you build, if you get it to work on your machine, it'll work on another machine. So that runs, I won't demonstrate that too much. So there it is running locally. Now if I want to say deploy something like that to Azure, we looked at Docker Hub as a place to put images. Docker Hub is generally free and open by default, but if I want to put my private images on, I can either pay Docker Hub and get a private account through Docker Hub, or I can use this feature on Microsoft Azure called the Container Registry. So the Azure Container Registry is there to receive Docker images that I've made. So I go and create an account with the Container Registry, and then I can take the Docker images that I've built locally and upload them to the remote Container Registry, and then I can point numerous things at that application. So things I can point up there include, and I'm going to skip forward a bit. So there's 3 places I can use to run a containerized image. I can put it on Microsoft Container instances or Azure Container instances. Those are useful. That's a useful Azure tool for taking a single container and just running it. And the problem with that is it doesn't give you much beyond that. It's just run this container. I use Azure Container instances if I want to run a whole bunch of load testing scripts, because it's really good for running 10 things, let them run, let them finish, don't look after them. The one in the middle, the Goldilocks zone for me, is Web App for Containers. That'll take your container and host it inside Azure Web App, which means underneath that Azure Web App, you've got a lot of the stuff, a lot of the APIs web apps give you. It's got a proxy server set up to terminate your HTTPS endpoints for you. It's got the ability to scale up or scale down. All those scaling triggers you can set up, normal for web apps, is available. So I can scale it up and scale it down in demand, or set up scripts to scale up and scale down just there inside web app. And finally, your kind of top level gold-plated option is Kubernetes. Kubernetes is not easy to learn and not easy to play with. But Kubernetes is the option where you've got a much more complicated architecture. If I was just to deploy a single web app that could scale up to 3 or down to 4, scale up to 5 and down to 2 machines, then Web App for Containers is great. If I've got a distributed architecture where I've got a product processing service that sometimes scales up to 3 and sometimes scales to 2, and then the user management service over here and a whole bunch of microservices, I want to get them all working together, that's the kind of level you want Kubernetes for. So Kubernetes is basically a container orchestration service, something for taking lots of containerized applications and building a whole structure of server-to-server communication on top of that.